Okay. So in this video, we're going to go over the chapter 6 review questions. And there's really not many of them. Maybe like 4-ish questions that we need to go over. Sorry. And all the questions in here are roughly the same thing. It's basically just, using the elimination and the substitution in order to solve the systems of equations. So this first problem, let's do, why does it say A, B, C, D? Oh, okay. Let's do 14. This is all on page 472. What starts on this page? So this is number 14. So we want to solve this equation. So we have 2x plus 3y. Sorry. 2x plus 3y is equal to 2. And 5x minus y is equal to minus 29. So we can either use substitution or elimination. In this particular problem, I guess maybe substitution is a little bit easier. So you see, if we take that second equation, 5x minus y is equal to 20 or minus 29, we could solve for y. So we could add the y over to the right and add the minus 29 over to the left. So what this equation gives us is 5x plus 29 is equal to y. And then what we could do is we could take our first equation, 2x plus 3y is equal to 2. So what we could do is then we could take this and plug it into this equation for y. So doing that, we're going to have 2x plus 3, and now we're replacing y with 5x plus 29. That's equal to 2. And then we just solve this equation for x. So we have 2x, then distributing the 3, so 15x plus, so what's 29 times 3? 87 is equal to 2. Let's see what we have here. So then we have 17x is equal to, then we can subtract the 87 over minus 85. Hopefully 85 divides by 17 well. Yeah, so then we can divide the 17 over. So x is equal to minus 85 over 17. And that's going to be equal to minus 5. So we have x is equal to minus 5. So there's one of our answers, but we need to find y. So what we could do is we could take any of our equations. Let's just take the second equation. So that second equation, let's just rewrite it. 5x minus y is equal to minus 29. Then we could do is we could plug this x equals minus 5 into here. So we get 5 minus 5, then minus y is equal to minus 29. Just replacing the x with a minus 5. So that's minus 25 minus y is equal to minus 29. Add the 25 over, we get minus y is equal to minus 4. And then we divide by the minus sign, so we get y is equal to 4. So two answers. We get x is equal to minus 5. Let's put those in green. So we have x is equal to minus 5. And then we get y is equal to positive 4. Okay, the next type of question that we're going to need is, let's do, so this is just an example. It's not in the book, but it's the same style. So this is 3x minus 5y is equal to minus 8, and 4x plus 3y. 4x plus 3y is equal to minus 1. So in this one, can't really do substitution that easily like we were able to do in the last problem, how we could easily solve for a variable. So maybe in this one, what we're going to want to do is do elimination. So we want to choose a variable and manipulate these equations in a way to add or subtract them to cancel out the variable. And so either variable in this particular problem is going to be just as easy or hard as the other one. So let's just try to choose to eliminate x. So right now in front of the x's, this one has a 3 in the front and this one has a 4 in the front. But we want to make those two numbers match. So an easy way to do that is we could turn both of those into 12s kind of easily. We can multiply this whole top equation by a 4. So if we multiply everything by a 4, we would have 3 times 4, which is 12. And then we could take this whole bottom equation and multiply it by a 3, because then we'd have 4 times 3, which is 12. So doing that, those two steps would get the number in front of the x to be exactly the same. So let's take the first equation and we're going to multiply it by 4. So 3x minus 5y is equal to minus 8. And let's take the bottom equation and multiply it by a 3. 4x plus 3y equal to minus 1. And so what that does is it gives us, so we have on the top, we're going to have 4 times 3, so 12x. Then we're going to have 4 times 5, so minus 20y. Then we're going to have 4 times minus 8, which is minus 32. And on the bottom, we're going to have 3 times 4, so 12x. 3 times 3, so 9y. And 3 times minus 1, so minus 3. So now we want to either add or subtract these equations. We have to choose. But we want to make sure that these x's cancel. So what we're going to want to do is actually subtract them, so then we'd end up having a 12 minus a 12. So we're going to subtract these two equations now. So the beginning is going to give us 12 minus 12x, which is 0. Then minus 20 minus a positive 9, so minus 29y. And then minus 32 minus a minus 3. So that's minus 32 plus a 3, which is going to be minus 29. So we divide by the 29s, or the minus 29, and we're going to get y is equal to positive 1. Okay, so we found one of our things. So now we just got to take any of our original equations and plug in y equals 1. Let's just take the first equation. So that first equation was 3x minus 5y is equal to minus 8. And then all we have to do is just plug this y is equal to 1 into here. So that's going to give us 3x minus 5 times 1, which is equal to minus 8. 3x minus 5 is equal to minus 8. Add the 5 over. 3x is equal to minus 3. Divided by the 3, x is equal to minus 1. Okay, so then we get these two answers. X is minus 1, y is positive 1. Okay, how about number 5? Oh, sorry. Well, this is number 5, but we're doing this a little bit differently. 5 through 12 says solve by graphing, but we're going to just continue doing these methods. Let's actually not do, what can we choose from? I guess that one's fine. So that's x plus y is equal to 7. And then 2x minus y is equal to 5. So in this particular problem, eliminations are actually kind of already done for us, because you see we have a y here and a minus y here. So we can just add these two equations together and those y's are going to cancel kind of automatically. So the first thing we're going to do is we're going to take our top equation, take our bottom equation, and then we're going to add them together. So we're going to get x plus 2x, which is 3x, y plus minus y, so they go away, and then 7 plus 5, which is 12. Divide by the 3, we're going to get x is equal to 4. Now let's just take our top equation, x plus y is equal to 7, and plug x is equal to 4 into here. So we're going to get 4 plus y is equal to 7. Subtract the 4 over, we're going to get y is equal to 3. So then we get these two answers, x is equal to 4, and then y is equal to 3. So as far as the equations that have two variables go, these are the only types that we're going to have. We did those ones previously where we had like x squareds and y squareds. That's not going to be on the test. So the test will be just similar to these 3 problems that we just did, maybe with just different numbers. I don't believe there's actually 3. I think there's only 2 of these types on the test. I'm not sure. That's not really important though. But yeah, what is important is that all the problems on the test that have the 2 variable ones that look just like this, where you're either going to use substitution or elimination. So the last 2 problems that we'll do is going to be the 3 variable ones. Okay, so for this problem, we have two x minus y plus 4z is equal to minus 3. X minus 2y minus 10 is equal to minus 6. And, oh, minus 10z. So let's see, we have everything right. So 2x minus y plus 4z is equal to minus 3. X minus 2y minus 10z is equal to minus 6. And then 3x plus 4z is equal to 7. So remember, when we're doing these ones, the easiest way to do these is through the matrix. So the first thing we're going to do is we're going to turn this into a matrix. So if you remember with the matrix, what we need is we need to have our columns, and the things that go in the front of the columns are the things that go in front of like the x's and the y's and the z's. So for this first row, we're going to have, if we just look at this equation, we just write down the numbers that are in front of the variables. So we have a 2 in front of our x, a minus 1 in front of the y, 4 in front of the z, and then a minus 3 over here. Then in the middle row, we have a 1 in front of the x, a minus 2 in front of the y, a minus 10 in front of the z, and then a minus 6. And we have a 3 in front of the x, a 0 in front of the y, a 4 in front of the z, and then a 7. So that's just all we need to do to set up the, let's fix the 7, set up the matrix. So now remember the steps. Our first goal is to make the thing in the top right a 1. The easiest way to do that actually is, well, let's just take our second row and replace it with our first row. So what we're going to do is we're going to put our old row 2 here, our old row 1 there, and then just rewrite row 3. So we're going to have 1 minus 2 minus 10 minus 6, then rewrite row 1. So 2 minus 1, 4 minus 3, and then row 3, which is 3, 0, 4, 7. Okay, so once we make that top left thing a 1, everything beneath of it needs to turn into a 0. So we have to make this a 0, and we have to make this a 0. So we're going to use row 1 to do that. So we're not going to change row 1. Row 1, just leave that the same. We have row 1. Now our row 2, we could take row, so to make this a 0, we could just subtract 2 of this from it. So we're going to take row 2 minus 2 row 1. And then this is a 3, so to make that a 0, we can subtract 3 of this row. So we're going to have row 3 minus 3 row 1. So now we're going to have, just rewrite row 1, 1 minus 2 minus 10 minus 6. Then, so row 2 minus 2 row 1. So we're going to have 2 minus 2 of this, which is 0, minus 1 minus 2 of that. So minus 1 plus 4, right? See, minus 1 plus 4, which is 3. Then this minus 2 of that, so that's going to be 24. This minus 2 of that, so minus 3 plus 12, which is 9. Okay, let's try to erase all these circles. So now in this bottom row, we have row 3 minus 3 row 1. So 3 minus 3 of this, which is 0. This minus 3 of that, which is just going to be 6. This minus 3 of this. So 4 plus 30, so 34. And that minus 3 of that, so 7 plus 18, which is 25. Okay, so erase that, that, and that. So we said before, it's always helpful to try to get rid of fractions, or not ever resort to fractions. So let's look at just these bottom 2 rows, because we could keep going the way we were doing before, and like the next thing would be to make, actually no, we can do that, let's do that. So once we said before was after making this thing a 1 and everything beneath of it is 0, we move down the diagonal and we want to make this piece a 1. That's our next step. And that's kind of easy to do in this row without getting fractions, because we can just divide that whole second row by 3. Everything in that row divides by 3, so we're not going to end up with any fractions. So let's take row 1. Let's take row 2 divided by 3, and I'll just rewrite row 3. So we're going to have 1 minus 2 minus 10 minus 6, 0. 3 divided by 3 is 1. 24 divided by 3 is 8. 3 divided by 3 is 9. Or sorry, 9 divided by 3 is 3. And now let's rewrite this bottom row. 0, 6, 34, 25. Now the next thing we're going to do is, like we said before, once we make, so we move down the diagonal, we make this a 1. Now everything beneath of that, we make a 0. So for this one, it's not too bad. All we have to do is we take our second row, or sorry, we take our third row and we can subtract 6 of our second row. So if we do that, we'd have 6 minus 1. Or sorry, so if we take our third row and subtract 6 of the second row, we'd have 6 and then minus 6 times 1, which is just 6. So 6 minus 6 is 0. So what we're going to want to do is, let's erase all these circles. In order to make this 6 is 0, so we're going to rewrite row 1, rewrite row 2, and then we're going to take row 3 minus 6 of row 2. So we have 1 minus 2 minus 10 minus 6, 0, 1, 8, 3, just rewriting those first two. Okay, now row 3 minus 6 of row 2. So we have the first bit, we have 0 minus 0, nothing changes there. 6 minus 1 times 6 is 0. 34 minus 6 of that, so it's 34 minus 48. Sure I don't make any mistakes. 34 minus 48, so minus 14. Okay, and then 25 minus 18, since 25 minus 3 times 6, so 25 minus 18, which is 7. Okay, let's erase these circles. And then if you remember, the last step is, or basically one of the last steps. So we did first step, we made this a 1, everything beneath of it is 0. Then we move down the diagonal, make this a 1, everything beneath of it is 0. Then we move down the diagonal again. We're going to make this a 1 now. So let's do that. To make that a 1, we can just divide that entire row by minus 14. So we're going to have row 1 the same, row 2 the same, row 3 divided by minus 14. So we have 1 minus 2 minus 10, 0, 1, 8. Oh, over here we have minus 6 and 3. Now 0, 0, minus 14 divided by minus 14 is 1. 7 divided by minus 14 is minus 1/2. Okay, so now what does this bottom row tell us? Well, this bottom row tells us that just z is equal to minus 1/2, because we would have 0x plus 0y plus 1z is equal to minus 1/2. So what this bottom row tells us, what row 3 tells us, is that z is equal to minus 1/2. So there's one of our answers. Now let's look at that second row. What the second row tells us is that y plus 8z is equal to 3. So then what we can do is we can just plug this z into here. So what we get is y plus 8 times minus 1/2 is equal to 3, which is y minus 4 is equal to 3, which is y is equal to 7. Okay, so now what does the first row tell us? Well, the previous first row, if we look right up here, we have x minus 2y minus 10z is equal to minus 6. And so now what we need to do is we have to plug our y into here, and we're also going to plug our x into here to solve for z. So to solve for x. So we're going to have x minus 2, y is 7, so we're going to plug in 7, minus 10, and then z is minus 1/2, so we're going to plug in minus 1/2 is equal to minus 6. So we have x minus 14, and then plus 5 equal to minus 6. So x minus 9 is equal to minus 6. And then we add the 9 over, we're going to get x is equal to 3. So we have these problems. or sorry, these answers, not problems. So we have z is minus 1/2, y is 7, and x is 3. Okay, so that actually takes care of all the problems from this section. So we don't think we really need to do much more. So just focus on these types of problems. And then also, the problems from the previous video. Yeah, and if anyone has any questions, just feel free to email me. I can, always just do some problems on a piece of paper and like send them back through email or something. Yeah, other than that, thanks and good luck on the test tomorrow.